Yes, today's class is about the relative motion. Under that, we consider relative velocity, relative speed, and relative acceleration, but mainly relative velocity. I'll explain first what is relative motion. When we consider any object in the universe, they move. Our galaxy is concerned, it's moving. So therefore, it is really floating like that in the space. If you consider our Earth, it rotates. It rotates and going around the sun. But these objects are concerned not at rest. But when you are on the Earth, we don't feel that the Earth is moving. We don't feel that. So therefore, we assume here the Earth is at rest. But that is assumption. If we consider the Earth is at rest, any motion or any object moves on the Earth relative to the Earth. That means when we consider certain object, with considering that object, here first time I'm saying Earth, we are moving. Then we can say the motion of that object relative to the Earth. Then we assume that the Earth is at rest. But it is practically wrong. Practically wrong, but we consider like that. Normally, when these motions are concerned, motion. So here I consider relative. Relative. That means with respect to another object. A car is moving on the earth. A car is moving on the earth. Towards that direction, we'll see. With a velocity of simple v. We assume the earth is at rest. This is earth. Assume earth is at rest. Earth is at rest. Rest means does not move. Then relative to the earth, the car is moving towards left. We'll say left there. Then the statement is going like that. Motion means move. Motion of the car, or without the also you can write car relative to the earth. When we denote this, we denote it like this. Motion for that notation there. Notation is M for motion of the car relative to, earth. This is the notation. Motion of the car relative to the earth. Then, if you consider about the velocity, then velocity of the car relative to the earth. That is the notation then. This is velocity. Velocity of the car relative to the earth. Statement, velocity of the car relative to the earth. Like that. If there is a velocity, we can write that is u anything. Then first note down. when we consider our galaxy, it also moves. Even our Earth, that also rotates about its axis and moving around the sun. For this section, we assume that the Earth is at rest. That is the assumption. If you consider motion of any object on the Earth, considering the Earth, that is called relative motion of the object, with respect to the Earth. Normally, in this section, we say it as velocity of the object relative to the Earth. Velocity of the object relative to the Earth. If we consider motion of the object, it is considered, or it is called, motion of the object relative to the Earth. Motion of the object relative to the Earth. Then, notation. Motion of the car relative to the Earth is denoted by motion m within brackets c comma e. That means motion of the car relative to, you consider that comma is for that, relative to the Earth. If it is the velocity, it should be written v within brackets c comma e. Note down these two. Motion is how it is going towards with the velocity means, we know velocity definition, that is displacement divided by time, velocity. Now consider another way. Now on the Earth is at rest assumption, that is our assumption. On the Earth, an object A, can call a car A, moving towards one direction. B is also moving, maybe towards the same direction, opposite direction, or any other direction. It is not a matter. But here we consider two observers. Observers means there are two people inside or passengers inside these two cars. A passenger or person in the car A observes means sees the motion of the car B then we call it motion of the car B relative to A. Who is observing? The person in A. If the person is in B is observing A, then we call it velocity, motion of the car A or A relative to B. Then where is the observer? He is in B. But if you consider that person is considered, the observer is considering the velocity, then we call it velocity of the car B with respect to or relative to A. That means observer is in A. If you say velocity of B relative to velocity of A relative to B, then observer is in B. Understood now? Got it. Right. Now, we have to write a note on this. Then write. Now consider two objects A and B moving on the earth. If an observer, who is in the object A sees or observes the motion of B, then it is called relative motion of B or motion of B relative to A. Relative to A. Then the observer must be in A. Observer must be in A. Then we'll consider there is another car we consider B. No? An observer in B, that means a person in B, observes the motion of A. Then it is called motion of A relative to B. Relative to B. Then we'll see how to write. Then start to write. How to denote these things. Or these are denoted by how it is they are denoted by. So this is a way. Motion of, then write, motion of A, motion of A relative to B. Motion of A relative to B is denoted by motion of A relative to B. Note down. Now next one, motion of B relative to A. Motion of B relative to A. Motion of B relative to A. Then motion of B relative to A. Now you can understand how to always relative to, after that we are mentioning about any object, the observer is in that object. Now we'll consider A and B are two objects, they are moving relative to the Earth. Then Earth is denoted by capital E. Then we can say velocity of A relative to the Earth, or motion of A relative to the Earth. Anything we can consider. V is velocity. E is given towards particular direction. We'll say V1 towards that direction. Velocity of B relative to the Earth is given to the same direction, P2, like that. But velocity values we'll discuss later. Now, we'll consider the theory related to relative motion. Then write the equation of relative motion. Next heading. The equation of relative motion. The equation of relative motion. Then write A and B are two objects moving on the Earth. That means they move relative to the Earth. Velocity is concerned, then write V AE. Velocity of A relative to the Earth is V1 towards this direction. Velocity of B relative to the Earth is V2 to the same direction. This is the equation. Velocity of A relative to B is equal to velocity of A relative to the Earth plus velocity of the Earth relative to B. This is the equation. If you consider P and Q, velocity of P relative to Q is equal to V PE plus V EQ. E comes in between P and Q. Not the. Now consider this is, you have to remember this. A to B, AE plus EB or PQ, PE. If you are considering acceleration, instead of V, you write A. Like that, it changes. Now, I'll consider the two objects. And here we have to add two velocities. Therefore, we have to use velocity is a vector addition. Then write According to this equation, we have to add two velocities. We have to add two velocities. Therefore, use vector addition theory. Vector addition theory. Use vector addition theory. Right, we'll see. Now, when the two objects are moving to the same direction, heading, relative velocity, when two objects A and B are moving to the same direction, having velocity of V1 and V2 relative to the earth, respectively. Then we consider velocity of A relative to the earth, V towards this direction. Velocity of B relative to the earth is U to the same direction. I said as a heading, they are moving to the same direction. Now, our theory, velocity of A relative to B is equal to velocity of A relative to the earth plus velocity of earth relative to B. After that, if you want, you can directly apply and add. But if it's better if you write like this, PQ plus QR, then the resultant or the vector addition is PR. This means the vector PQ, straight line PQ with the direction and magnitude, that is represented VAE. VEB is represented by QR. Then VAB is represented by PR. But here triangle is not there. The reason is they are moving to the same direction. We'll consider like this. First, velocity of A relative to the earth is V. But here it is opposite direction. Then opposite direction velocity. Velocity of E relative to B is the same magnitude but to the opposite direction. I will explain that with a certain practical manner. I think you have gone by train. When the train is at rest in a particular platform at a station, and when the train starts to move from zero velocity and it increases or getting increased its velocity because of engine, then if you look at only the pillars, there are pillars on the platform. You feel that the pillars are moving backwards. Pillars are moving backwards. Pillars are on the earth, no? So that means it is just like what? Earth is moving backwards. Normally, a person on the earth, somebody is on the earth, can see the train is moving to right. We'll say moving to the right. Then person in the train sees the earth. The earth means there's trees and other things, what we can see, moving backwards. That means first one is velocity of the train means the person inside will say, relative to the earth is towards this direction V1. Then second one, observer is where? In the train. So therefore, velocity of the observer, velocity of the train here, velocity of the earth relative to the train. Train means the observer there. We consider or we feel they are moving to the opposite direction with V1. That is obvious normally when you are going by car. Like that, if you going to this direction with 10 ms minus 1, the objects on the earth all are moving backwards. First one is, somebody can see we are moving relative to the earth. Now we are in the car. According to the relative to the car, the earth is moving to the opposite direction. Always, if you change two letters, direction must be changed. Then note down this. Right, next one. Only this. Now this is applied here. Now we'll see what's happening with this. Velocity of A, it's moving to this direction. There are two situations I have to consider. Without considering, I'll tell it. After that, I'll consider and say. So here, see, that is V. And after that, this is PQ. P to Q. Direction is this. Then QR is EB. This is V. EB. EB is QR. The QR direction is opposite direction. So therefore, R may be here, R may be somewhere here, or R may be right on at the same position. It can be because the other one is U. No? If U is less than V, R is here. If U is equal to V, R comes to this position. If U is greater than V, so it exceeds here. Then there are three conditions. Then, right, here we consider three conditions. Here we consider three conditions. Number one, U is less than V. Number one, U is less than V. Number two, U is equal to V. Number three, U is greater than V. There are three situations. First you write up to this. Then we'll start to do. First you come up to this. And after that, we'll say first situation, U is less than V. Then our position is P to QV. Then Q to R, that is U, but U value is less than V. So R must be somewhere here. Then red one is U. Then our value PR. Here PR. PR is equal to PQ minus QR. PQ is V, QR is U. Then this is V minus U, PR value. Direction, P to R. Why PR? So that means as same as the direction they are moving. They are moving to the right. This is right again. The direction is that. You understood? R is here, P is here, therefore PR is towards that direction. If you want, you can draw two arrows on here. Arrowheads. First situation, consider like that. Then write from here up to this point. Now, second situation. Second situation, U is equal to V. Now, when U is equal to, I'll alter here and write, U is equal to. Now, what happens? P to Q is V and U is the other one. It should be equal to V. That means red line should come up to P again. Then R is here. P is identical position with R. Then PR value, PR is equal to 0. Why? P to R, no distance. Then relative velocity is 0. Or we can say velocity of A relative to B is equal to 0. Null vector. Then right? When we consider second situation, U is equal to V. That means the QR vector magnitude is equal to magnitude of PQ vector. In other words, R comes to the same position of P. Then P and R are at the same point. They coincide. then PR distance is 0. In other words, relative velocity is 0. That means velocity of A relative to B, velocity of A relative to B is 0. That's magnitude. But in this, since it is null vector, normally I didn't say when we were doing vectors, null vector direction is not there. So therefore we can say arbitrary direction, any direction, arbitrary. It's arbitrary direction. Then write from here up to this. Now third situation. Third situation is U is greater than B. U is greater than B. Now starting from here P, it goes to Q and then QR. That's QR is coming backwards and coming backwards greater than the value of, then R is here. Then look at this. The red one, PQ value is towards that direction. V, this is U. Then PR is equal to PR value, that is RP, we'll say, is equal to QR, PR value is equal to QR minus PQ or QP. So PQR is V, U, and QP is, that is V, minus V. Then PR value is U minus V. Direction, the opposite direction of the direction, opposite direction, direction of UOV. They are moving to right. Here it is to the opposite direction. Example. Now, first one, that is for the first situation. A car is moving towards east with a velocity of 20 ms minus 1. A lorry is moving to the same direction, that means moving to the east, with a velocity of 12 ms minus 1. Find the relative velocity of the lorry or find the velocity of the lorry relative to the car. Find also the relative velocity of car relative to the lorry. That should be opposite direction as a same. Now, if when you are doing for the second paper, when you are doing it for the second paper, this is how you start. First you start with E is earth, car, C is car, L is lorry. Then velocity of the car relative to the earth is 20 ms minus 1 to the east. East is towards this direction. Then velocity of the lorry relative to the earth is 12 ms minus 1 to the same direction. Then I am asking velocity of the lorry relative to the earth. First one. This is velocity of this is what we are trying to find. Then theory, according to the relative velocity equation, even better to write it. According to the relative velocity equation, LE is equal to VL. Then we want to find relative velocity of the lorry relative to the car. So then lorry relative to the car. VLE plus VEC. VLE. VLE is 12 towards this direction. But normally we write PQ plus QR. That is PR, one method. Directly also you can write the values there. Then PQ value is LE is PQ. Second one EC. EC is not here. From this we can get, this is VCE. We want to get, or if we want to get VEC, E comma C is 20 ms, same magnitude to the opposite direction. Then you consider PQ from P to Q. PQ value is LE. LE is 12. Then car. Velocity of the lorry relative to the car. Then car is moving to the same direction. First we got VLE. VLE is 12. Then the other one EC. EC is 20 to the opposite direction. Then PQ, QR. This is R and it is 20. Then PR. PR is concerned, what's happening? We want to get a value for PR. PR is QR minus QR minus PQ. 20 minus 12, that is 8. MS minus 1. Then we'll see again. Now, don't write. I said a car is moving to the east with a velocity of 20. Lorry is moving to the same direction with the velocity of 12. Now, velocity of the lorry relative to the car. Where do you get the observer now? In the car. Car is moving fast. So we'll say myself is a car, another one is there. That is a lorry. I am moving with 20 for this direction. Lorry is also moving to this direction. Basically, practically, I am overtaking the lorry. Why? I'm having higher velocity. So then I can observe the lorry is moving backwards. Why? I'm moving over by overtaking the car. That means I'm the car. Lorry is going backwards like that I feel. What I observe is lorry is moving backwards. Backwards means if this is the east, then west. Now PR is concerned, what is the direction? P to direction, P to R, that means west. Correct? That is, then do the question after that. Sometimes in school, they are without writing PQQR like that, they are just writing the values here. But sometimes getting confused. When you have the directions and all, right answer can be obtained easily without any problem. Then write, therefore, velocity of the car. We found velocity of the lorry relative to the car. We found velocity of the lorry relative to the car is 8 ms minus 1 towards this direction, that means west. Then velocity of the car relative to the lorry. When you find this, you can write it. Letters are being changed, or when you want to change the letters, then you have to change the direction. 8 ms minus 1 to this direction, east. Now velocity of the car relative to the lorry. Lorry is moving slowly. Car is moving fast. Then the person in the lorry can see it's overtaking. The car is overtaking and moving forward. Forward means to the same direction, east. But using this method also we can find. For MCQs, if you find that, the next one they ask, you change the direction and write it. That is the answer. Now again consider this method. Now I want to find velocity of the car relative to the lorry. It's like normal method. Velocity of the car relative to the lorry. Velocity of the car relative to the lorry is equal to V CE plus VEA. If you consider this is PQ and this is QR, then PQ plus QR means PR. Now we require not this one. We require velocity of the earth relative to the lorry, EL. That is 12 ms minus 1 to the opposite direction. That is west. Then what do you get? Here, first one PQ. P to Q, CE, CE is 20. PQ. This is 20. Then QR. QR is EL. EL is to the opposite direction, means west 12. From here, it should come back 12. And R must be here. Then our value is PR. PR is equal to PQ minus QR. Longer method. 20 minus, this is R, and this is 12. 12. That is 8 ms minus 1. The direction P to R. P to R, this is the direction. Direction P to R. P to R means east. That means the car is moving towards the same direction. Okay, then right from here. Better to start from here and rewrite it. That is a longer method. But when you find this, if they ask the opposite way, get the value 8. That is not east, then that is to the opposite direction, west. Sorry. Here it's moving to PR, east, that's west, RP. Now we'll come to another question. Next one. A car is moving to north with a velocity of 20 ms minus 1. A lorry is moving to the same direction, that is north, same direction, with the velocity of 20 ms minus 1. Find the velocity of the car relative to the earth. Sorry, find the velocity of the car relative to the lorry and find also velocity of the lorry relative to the car, the opposite way. Now, I gave you the same magnitudes. Now, the first one is the car is moving towards the, now car is moving towards north. This is north. Car is moving towards that north. So then velocity of the car relative to the lorry is towards this direction 20 ms minus 1. First you better write C is car, then L is lorry, E is earth. Second paper, in CQs there is no need to write like that. You don't want to write anything there. Now, after that, you have to consider velocity of the lorry relative to the, first one is velocity of the car relative to the earth, 20. Lorry relative to the earth to the same direction, 20 ms minus 1. Relative to the earth both, because they are moving on the earth. I want to find velocity of the lorry relative to the car. So velocity of the lorry relative to the car, this is the theory or equation of relative velocity. V L E is the, then you have to start with E here and ending with C. L E E C. Then L E, no, E C. V E C is equal to downwards 20 ms minus, that is south. This is north, this is south. Now, this is PQ, this is represented by QR, then answer comes with the vector PR. Then PQ, PQ is LE, L is 20, 20, PQ, that is 20, ms minus 1. So, last time I did not write the units. Then EC, EC is downwards 20. It should come, QR is again 20, R is here, 20. Then P is identical to R. Therefore, PR is equal to 0. So, relative velocity is 0. That means velocity of the lorry relative to the car is 0. No particular direction. Therefore, velocity of the car relative to the lorry also 0. When the relative velocity is 0, that means both are moving together. Moving together. That means they are moving like this. If one is having a larger speed, one is overtaking. Both are moving together like that. You have seen, but from the computer now we can make those things, right? But those days, early stages of Indian films, you have, I don't know whether you have watched those. Some person is jumping from the train to the other train, right? You think that it is very interesting case like that. What they do is they film the first one is moving fast. Second one is also moving fast. Then both trains are moving together now. It's a slow motion. Slow means velocity is 2 or 3 like that. Then you can jump from here. Nothing would happen. Even you can hold the bar and keep your leg to the other train and move to that. Right? Both are moving with the same velocity. Relative velocity is zero. Right. Do up to this. Now, same direction, same values, moving together. Right. Next one. A car is moving towards northeast. Northeast with a velocity of 8 ms. A lorry is moving. No, I said car, no, first one. A car is moving towards northeast with a velocity of 12 ms minus 1. A lorry is moving to the same direction with a velocity of 2 ms minus 1. First one is 8 m, make it 8 ms minus 1. Second one, 2 ms minus 1. Car 8 ms minus 1. Lorry 2 ms minus 1. No, we'll make it lorry 12 ms minus 1. 12 ms minus 1. Find the velocity of the velocity of the lorry relative to the car and velocity of the car relative to the lorry relative to the car. Second one, car relative to the lorry. Now you should remember the directions. This is north, this is south, east, west. Then if the inclination is 45 from this main direction, this is considered as main direction. Then there are another four directions. This is 45, this is 45. From north, we say the directions. From north towards east, northeast. From north towards west, northwest. From south towards west, southwest. From south towards east, southeast. Anyhow, note it down. Main one is south north or north south line. Again, you can write C is car. I'm not going to write it. And further, you have to write when you are starting. You have to start from velocity of the car relative to the earth is towards E. That is, I said southeast. Southeast, this is southeast. With the car is moving with 4 ms minus 1. We'll consider like that. Then velocity of the lorry is from here 45, 45 and 12 ms minus 1. Then we want to find velocity of the lorry relative to the car. Velocity of the lorry relative to the car is equal to velocity of the lorry relative to the earth. So E must come in the middle plus VEC. So this is PQ plus QR and it is equal to PR. Then PQ is LE, that is given. EC, velocity of earth relative to the car is, then we have to make it to the opposite way. This is 45, so then this is 45. And it is 4 ms minus 1. Then PQ, you can draw PQLE 12. P to Q 12. Then if you want, you write ms minus 1. Then QR. QR is EC 4. It's coming towards this direction. 4. ms minus 1. Then this is R. Then you can find PR. PR is equal to PQ minus QR. So that means 12 minus 4, that is 8 ms minus 1. PR. Then direction P to R, that means southeast. Sorry, northeast. Northeast. When you want to get the other way, first you do like that. Right. Now we'll consider the other way. That means when you want to find velocity of the car relative to the lorry, that is to the opposite direction. So 8 is minus 1. Then this direction is northeast. The PR is northeast. Now this direction southwest. When you change the letters, the opposite direction. Long way also I'll do this. When you consider the long way, this method, then here we want to find CL, then CE, EL. CE, EL. EVEL is to the opposite direction towards EC early. Now EL this direction, 12 ms minus 1. So this is also southeast. This is no. This is concerned. Yeah, I did it. I think northeast. This one, northeast. Consider northeast there. Then this is southeast. Towards that direction, northeast. Change it. Now, when you consider this, PR, PQ, VCE plus VEL. Now we'll consider PQ, VCE. This is PQ, only 4. Then the other one is QREL, south, that is southeast, not southeast. This is northeast, southwest. Then southwest, you have to go for 12. That is R. Then PR is equal to PR. PR is equal to, from P we drew the first term. PR is equal to QR minus PQ. 12 PR is 12 minus 4. That is 8. M is minus 1. Now direction, it is P to R. P to R. That is direction. P to R is southeast. That is southeast. So then 8 ms minus 1 southeast. That is the answer. Check whether I have marked it as southeast early. Check it and get it corrected. Anyhow, you can do like this. Quickly finish it. Those are on one particular straight line. Same direction, like that we got. Next one. Next one. When the two objects are moving to the opposite directions, the same direction we consider three different situations. But here we don't have three different situations. Now we'll consider a car is A and B O like that. Velocity of the car relative to the earth, that is V towards this direction. Then velocity of the lorry relative to the earth is to the opposite direction, U. Then velocity of the car relative to the lorry, or velocity of the lorry relative to the car. We'll find this first. Velocity of the lorry relative to the car is equal to velocity of the lorry relative to the earth plus velocity of the E should come here, earth relative to the car. Then this is PQ, this is QR because vectors are to be added. We have to use vector triangle like that, but straight line we are getting it, PR. Then PQ is concerned from P to Q, LE. LE is P to Q towards this U. Then we want to find EC. VEC is equal to, because I changed the letters, then the direction must be reversed, opposite direction. Then that is V. Then from P to Q, P to Q, Q to R is V. Q to R. This is V. Then our answer is PR. PR is PQ plus QR plus. Then U plus V. So then direction P to R. P to R means the direction of which one? First one. U is velocity of the lorry. Towards that direction you get P to R. I will explain in a natural way. First you note it down. Now I'll explain this. Now the first situation, a car is moving towards this direction. We'll say this is the direction. Car is moving. The opposite way, the other one is coming, lorry. Lorry is coming towards this. First one is velocity of the lorry relative to the car. Now the car is moving like this. Lorry is coming to the opposite direction. The person in the car, relative to the car, can see the lorry is passing him. It's going backwards. So see, we got the answer as PR. So PR is opposite direction. Understood now? So then that is U plus V. The first one is PQLE. Now when we consider the person in a lorry, so that is a lorry is moving to that direction, you will see. Lorry is moving to this direction. Now lorry is moving this direction, car is moving to the opposite direction. Then lorry driver or person in the lorry can see the car is passing. Then what we have to do is we have to reverse the direction. That means velocity of the car relative to the lorry is to the, now we got it P to R, now it is R to P. R to P is this direction. The opposite direction you get. Example. A car is moving towards east with a speed of 20 ms minus 1 towards east, and a lorry is moving with a velocity of 10 ms minus 1 to the west. This is east, this is west direction. Find the velocity of the car relative to the lorry, and find also velocity of the lorry relative to the car. First one we can go like that, same way. Then first one PQ, LE. LE is 10, EC is 20 to the opposite way, ms minus 1. Now, earlier I did not write this one. Now we have experience, so therefore we write the units also there. Then first one, P to Q. You have to find P to Q, first one. P to Q is LE. Then here P, Q is here. Then it is 10 ms minus 1. Then Q to R. Q to R, EC. EC is from here, R is here, 20. Then our answer is PR. PR is equal to PQ plus QR. That means PQ is 10, this 20, altogether 30 ms minus 1. The direction PR is west. Direction is west. Car is moving to the east, lorry is moving to the west, actual direction. Add in the two values and we can see, the person in the car can see lorry is going to the west. If the person in the lorry is concerned, lorry is moving to the west, this is moving to the east, then that person can see the car is moving to the east. R to P. RP is east. Therefore, VLC is opposite direction, west. Same value, 30 ms minus 4. Because we change the letters, then value is the same, direction is opposite. That can be obtained by changing this. Right, we'll see the next one. Right, next situation. Now, I'm giving some example when the objects are moving to two different directions which are perpendicular to each other. Perpendicular to each other. One is moving to this direction, other one upwards or downwards like that. Or normally on the ground we can say upwards and downwards. East, if it is moving to the east, maybe north or south like that. Then right. A car is moving towards west with a velocity of 8 ms minus 1. A lorry is moving towards south with a velocity of 6 ms minus 1. Find the velocity of the lorry relative to the car and also find velocity of the car relative to the lorry. There is no need to do twice. Direction is reversed, then you get your answer for the second part. Now, when we know about the directions, north, south, then this is west, east. So then, velocity of the lorry relative to the car is equal to velocity of the lorry relative to the earth plus velocity of the earth relative to the car. Now, this is PQ, this is QR, then relative value is PR. Now, LE known, EC is not there. So we have to consider BEC. EC means CE to the west, then EC to the east. Right? Towards that direction, 8 ms minus 1. Now, PQ. PQ is LE. Then you can draw P here, Q downwards, and the value is 6 ms minus 1. PQ is LE, L is downwards. That means out. The other one is east. EC, QR. QR is 8. This is 8 ms minus 1. Then relative value is PR, P to R. Now vector triangle came. Now what we had to do is we had to find PR value. PR squared is equal to Pythagoras. PQ squared plus QR squared. PQ squared is 6 squared plus 8 squared. 36 plus 64. Altogether 100. So therefore PR is equal to square root of 100. You can say plus or minus, but positive value is enough. 10 ms minus 1 there. Then the direction, that is also important. Now relative velocity is 10 ms minus 1. Direction P to R. Then get this angle from here. From this is south towards east. Angle is theta. Then tan theta is equal to tan theta is equal to in this triangle opposite QR divided by adjacent PQ or QP. 8 divided by 6. That means 3, 4. 4 by 3. Then theta is equal to tan inverse. Inverse means get the value and find from the book. But there is no need to write like that. Find 4 by 3. Tan inverse 4 by 3. That is enough. Then your answer is to be stated or written, saying that the velocity of the lorry relative to the car is 10 ms minus 1, making an angle of tan inverse 4 by 3 from south towards east. But I'll give the answer. You do it and statement will be given by me. I can dictate it. Right. Quickly finish it. Now, without doing, I will do this one in the other way also. But before that, I'll tell how to get the answer. Therefore, VCL, velocity of the car relative to the lorry, is to the opposite direction. Opposite direction, and value is to 10 ms minus 1. Now we have to see the opposite direction. That means like this. Parallel to this will draw opposite direction. Then this angle is theta. Because if you draw like that, this is theta. Then this direction is north. This is towards west. This is west. So therefore, the answer should be. But before that, you write the statement for the previous answer. This one. Then write velocity of the lorry, velocity of the car relative to the lorry, velocity of the car relative to the lorry is 10 ms minus 1 towards, or we can say minus 1, making an angle of tan inverse, this one, 4/3 from south towards east. From south towards east. Then write, when we want to find the, or when you are getting the velocity of the lorry relative to the car, that is opposite to that early direction, but having the same magnitude, 10 ms minus, having the same magnitude, 10 ms minus 1. Then what happens? Then you can see the direction. Direction is opposite. This is P to R, this is R to P. This is north, this is west. So theta can be told from north to west. Therefore, state it, note it. Velocity of the lorry, velocity of the car relative to the lorry is 10 ms minus 1. Velocity of the car relative to the lorry, 10 ms minus 1, making an angle of tan inverse 4/3, making an angle of tan inverse 4/3 from north towards west. From north towards west. North towards west. We'll try to get the same using the longer method. Here we want to get velocity of the car relative to the lorry. Then CEEL. So then EL is not done here. VEL is equal to 6 ms minus 1 towards north. Now PQ, CE. CE is P to Q. That is Q 8 ms minus 1. Then Q to R EL. EL is upwards. Right? EL is upwards. But here I don't have space to draw EL. Then I will draw from the bottom. This is PQ 8 ms minus 1. This is Q. Then QR is upwards. It's 6 ms minus 1. 6 ms minus 1. This is R. Now it is PR. Using Pythagoras, PR squared is equal to PQ squared plus QR squared. Then 8 squared plus 6 squared, same way, find it. Then PR is equal to 10 ms minus 1. Same answer you are getting. Then the direction is I consider from here, theta. If you want, you can say from there. Yeah, earlier I said from there. Then if it is there, tan theta is here. Then tan theta is equal to PQ divided by QR. 8 divided by 6. Then 4, 3. Theta is tan inverse 4 by 3. That is how we are saying the values. So same angle here. But if you want, without considering the same method, you can find alpha. If you are writing alpha, then tan alpha is equal to opposite divided by QR divided by PQ. Then QR is 6 divided by 8. 3, 4. Then alpha is equal to tan inverse 3 by 4. So if you are saying like that, we can say it the velocity is relative velocity is equal to 10 ms minus 1. The angle is concerned making an angle of tan inverse 3 by 4, not 4 by 3. From west to north. From west to north. Both answers are correct. Not done. Once you get this answer, if they are asking the opposite way, LC, reverse the direction and tell it. There is no need to do like this. I think you have completed now. Even any student have a problem, what you have to do is stop the video. If I get the recording, some YouTube it's there normally, or you can call me. And then stop it and write it. Pause it and write it. Okay, now I'll do another question, another example. An aeroplane is flying. An aeroplane is flying towards west with a velocity of 20 ms minus 1. Aeroplane, I'll write it as P, plane, relative to the earth, 20 ms minus 1 towards west. A man is walking, oh no, we'll say car. A car is moving towards north with a velocity of 10 ms minus 1. That is towards north. How the pilot of the plane sees the motion and velocity of the car. How the pilot of the plane sees the motion and the velocity of the car. Now one is flying above the earth, the other one on the earth, but direction wise, nothing to be worried. So then we want to find how to see the pilot. Who is observer? Pilot. So then velocity of the car relative to the pilot. Observe, pilot is observing means velocity of the car relative to the pilot we want to find. So then velocity of the car relative to the plane is pilot. Then velocity of the car relative to the earth plus velocity of the earth relative to the pilot. This is PQ plus QR. Then you get PR. Or some students would like to write without this. I'll do one or two examples without writing this, but it is confusing sometimes. Then first one is VCE. It's there. Then VEP. From this we can get VEP. Letters are changed. The direction should be changed. Then 20 ms minus 1. First one is CE. 10 up. So then here we have to consider P here, Q here, and it is 10. ms minus 1. Q is here. Then QR. QR is EP. EP is towards this direction 20 ms minus 1. Here R. This is PR. Now we want to find PR value and the direction. This is, what is this direction? North. Now this direction is east. But here north, this is east. Then what is this direction then? From north to east. North to east. the pilot can see, the value can be found. The car is moving not towards north. The pilot can see the car is moving towards this direction, making an angle of tan inverse certain value from, this is the north towards east. North, here east. We'll find the values now. First, we'll consider Pythagoras. PR squared is equal to PQ squared plus QR squared, whole number 1 becoming. So PQ is 100 squared, 20 squared, then 100 plus 400. So that means 500. So then PR is equal to square root of 500. That can be written as pi into 100 square root. Square root of 100 is 10. Square root of 5 into 10. So we can write 10 square root of 5 ms minus 1. Then you have to find tan theta. Tan theta is equal to, in this one, opposite PQ divided by QR. Sorry. The opposite is QR. QR divided by PQ. QR is 20. PQ is 10. Then this is 2. Theta is tan inverse 2. So your answer must be, the plane is moving with the speed of, car is moving with the speed of 10 square root of 5 ms minus 1, making an angle of tan inverse 2 from north towards east. That is how the pilot sees it. Again, I'll explain this one. I asked, the motion I asked, motion is direction. So, direction of the velocity, direction of the motion, both are the same. So, when you consider like that, you are going to north. Then your motion is towards north. Your velocity is also to the north. So, therefore, velocity direction is the same as the motion direction. That is what you have to understand. Then, when the question asks how the car, motion of the car is seen by the pilot, that means velocity of the car relative to the pilot. If the question is asked how the driver of the car sees the plane, then opposite one. So the same value to the opposite direction. We'll get that also later. Go ahead. Right. Next one. If this question is asked in the other way, then note it down. How the driver of the car sees the plane. Then we have to find velocity of the plane relative to the car. We found the value, velocity of the car relative to the. So then value is same. That means 10 square root of 5 ms minus 1. Now direction is to be reversed, opposite direction. This is from north to east. Now when it is reversed, same angle is here, theta. Then this direction is south. Then the direction is from south to west. This direction is west. South to west. This is north to east. Then right. Then the direction is same. The value is same, tan inverse 2, but the direction is from south to west. Now I consider two different levels. Plane is flying above the earth. Car is moving there. Such situation is it 200. Now we'll see another example. Then right. A man is walking towards west with a speed of 4 ms minus 1. Velocity of the man relative to the earth is 4 ms minus 1. Note it down, the question. Towards west. It rains. It rains with a speed of 3 ms minus 1. Normally it rains, no wind like that, vertically down. So then velocity of the rain relative to the earth is vertically down. Here it's like this is vertically down. Right. Then find the velocity of the rain relative to the man. Relative to the man. Then right. First we'll found it. We can find it. And then opposite way also ask. And find also the velocity of the man relative to the rain. So then rain is 3 ms minus 1. Velocity of the rain relative to the man, we have to find. Velocity of the rain relative to the man is equal to velocity of the rain relative to the earth plus velocity of the earth relative to the man. Then this is PQ and the other one is QR. Then this is PR. Now we'll consider PQ. PQ is velocity of the rain relative to the earth. So then RE, QR, EM. So from here we have to write VEM. VEM is to the opposite direction, 4 ms minus 1. Now PQ. So what is the direction PQ? RV. Vertically down 3, then QR PQ3. Then EM 4. R, this is 4, MS minus 1. PR is this. Now what is PR? PR is Rn. Velocity of the rain relative to the man. Then we have to find PR square. PR square is equal Pythagoras. We have to use PQ square plus QR square. Then PQ square is 3 square. This is 4 square. 9 plus 16. Altogether 25. Then PR is square root of 25. Plus value is always of 10. Or we are taking, because normally when you get square, plus or minus both are correct. But here plus velocity only. Therefore 5 ms minus 1 PR. Then we have to know the direction. So then here I'll consider direction from here. Then this is theta. Tan theta is equal to opposite divided by adjacent. QR divided by PQ. 4 by 3. Then theta is equal to tan inverse 4 by 3. Now we can say this is vertically down, the rain. Then how it happens? It rains, or the man can see the rain is coming towards him. Where is he going? Man is moving towards west. This is the man direction. The rain is coming towards. Then making an angle of tan inverse 4 by 3 from vertical towards him. So he can see he is moving to this direction. We'll say this is the west. Rain is coming like this. Understood? Then do up to that. Bring that color, umbrella quick. Umbrella, that color. Next one, we'll say the velocity of the man relative to the rain, then is the opposite way. Then write velocity of the man relative to the rain. Magnitude is 5 ms minus 1 and it is opposite direction. That is RP. That is RP. Next question. Next question. A boy is moving towards east. Moving towards east with a velocity of 8 ms minus 1. It rains with a speed of 6 ms minus 1. A boy is moving under an umbrella. What is the best direction he has to hold the umbrella? He has to hold the umbrella. A boy is moving towards east with 8 ms minus 1. The rain is R. It rains normally vertically down. Therefore, I said speed. So speed is 6 ms minus 1. We know it rains downwards. Now we want to find the direction the umbrella should be held by the boy, the best direction. You can hold in different ways. But velocity of the rain relative to the boy should be found. Because he has to observe how the rain comes. Who is observing? The boy. Then we have to find velocity of the rain relative to the boy. Now, velocity of the rain relative to the boy is equal to velocity of the rain relative to the earth plus velocity of the earth relative to the boy. This is again PQ plus QR and this is PR. Now we'll consider PQ. Now don't get confused with this R and this R. This is a vector, this is rain. Then PQRE, it is known. QREB. So velocity of E relative to B is equal to 8 ms minus 1 to the opposite direction. Right. Now we have to go ahead with this. And first one is PQ. PQ is RE. R is vertically down 6. Then after that, this is PQ. The value is 6 ms minus 1. After that, the other one is QR. This is R. That is 8 ms minus 1. R is here. Then we want to get PR. PR is towards that direction. Now, we have to find PR square. To find the PR square, use Pythagoras. PR squared is equal to PQ squared plus QR squared. PQ is 6 squared plus 8 squared. 36 plus 64. Altogether 100. So PR squared. So PR is equal to square root of 100. We consider only positive. Otherwise here you would write plus or minus. Then PR is equal to 10 ms minus 1. 10 ms minus 1. Now the direction from the vertical always you find. This is theta. Tan theta is equal to opposite. This is the opposite. Divided by adjacent. Opposite is QR. Adjacent is PQ. That is 8 divided by 6. 3, 4. 4 by 3. Theta is equal to tan inverse 4 by 3. So then we can say that it rains how? Relative to the boy, it rains, making an angle of tan inverse 4 by 3 from vertical towards him, because he is walking towards this direction. Then towards him. Then I asked only the direction. Therefore, this part is not needed. Right? You note it down and say it is not needed. Because I asked the direction. So what is the direction? An angle, certain angle. So then you have to hold the umbrella like this and see. Wait, I try to show you that. If I can open this umbrella, I'll show you. Okay. So then, here, I don't know. So this is the direction. So you have to hold the umbrella like that and move. Normally in Sri Lanka, wind is coming. So therefore, from the other side also you are getting wet. Otherwise, if it is always raining vertically, it rains vertically, you have, even that you have to hold like that and go. Don't hold like this and then your head is and or everything is getting wet. So here, this is the way. Actually, these umbrellas are concerned not used for the rain initially. You can go Google and see. It was used to get rid of the sun. There's a story. Once in UK, England, a person is in the, normally it is for the sun. So those days, most of the ones are different colors. But one day, one person is holding it and going under the rain. After that only that starts. There are so many stories like that. Right? You Google and see. Okay then, come up to this. Then I'll give you the last one. Same thing, but it is drawing method is different. Example. A car is moving towards north. With a speed of 8 ms minus 1. With a speed of 8 ms minus 1. And it rains with a speed of 6 ms minus 1. Find the velocity of the rain relative to the car. How the driver of the car sees the rain. Now here the problem is different. So velocity of the car relative to the earth, velocity of the car relative to the earth is north and 8 ms minus 1. North. This is north. But the thing is, other one, velocity of the rain, we have another problem here. Because we have to consider downwards. This is downwards. Vertically down. 6 ms minus 1. When you look at this is just like opposite direction motion. It's not like that. It is difficult to draw now. Therefore, what we do is, we want to find velocity of the rain relative to the car. What we do is totally different story. Here, normal direction, this is north, this is south, this is west, and this is east. Now our problem is, north and the vertically down, both are having the same like that, no? So therefore, our diagram, we turn this by 90 degrees. Then what happened? North is here now. North is here, then south is here. Then east is here, west is there. We turned it. Now we marked according to this. Then this should be velocity of the car relative to the earth is 8 ms minus 1. We said north, no, our north is now here. Then we can draw it. Velocity of the car, velocity of the rain relative to the car. That is VRE plus VER. VRE plus VER. Then VRE. What is VRE? PQ plus QR. This is PR. Now PQ. What is PQ? RE. Now that is vertically down, it's correct. This is the one we have to change. Then QR is, RC. This is C. Is VREEC. EC is now opposite way. Then VEC, comma C is 8 ms minus 1 to the opposite direction. Then in our diagram, PQ is RE, then the other one, now PQ, RE. R is vertically down. We'll say PQ. Then EC is QR from here towards that direction R. This is 6, this is 8. Then PR is that. Then we have to find this angle from the ring. Then you can use PR, Pythagoras. PR squared is equal to PQ squared plus QR squared. Then this is equal to PQ is 6 squared plus 8 squared, 36 plus 64, then 100. Then PR is equal to square root of 100. So that is 10. MS minus 1. Then tan theta is equal to opposite QR divided by PQ. Then again 8 divided by 6, 4 by 3. Theta is tan inverse 4 by 3. Then direction is concerned, then we can consider what is the direction the car is moving. Car is moving to this direction. Car. So then towards the car, it rains with a speed of 10 ms minus 1 towards the car. This is arrows must be towards this direction then PQ plus QR PR towards this direction. That means making an angle of tan inverse 4 by 3 from the vertical towards the car. Car is moving them towards the car. Note down. That is the last one. I explained everything. Earlier there was another type of question, that is crossing a river like that. Those questions are not in the new syllabus. In the paper classes sometimes I do. Otherwise it's not needed. Okay then. That is the last thing.